This
So
conference will
wherever,
now be recorded.
so this course would be for 3 months, and it would run on Indian Standard Time, 7 a.m. to 8 a.m. And wherever you are in the world, you just need to adjust to that particular timing. I'll just give some basic logistics. So this is a 3-month course, and then 1 hour daily, Monday to Friday IST. So if it is, for example, if you are in US, it would go from Sunday night till uh, Thursday night, right? Friday night would be free for you. It go from Sunday night to Thursday night. And 1 hour daily, most probably the timings would be 7 a.m. to 8 a.m. IST. All right, so these are some of the basics, basic logistic figures. And what today we'll see is we'll see like what are the prime topics we will be talking about. I would also go through the curriculum to show you like what are the topics we would be looking into the course. So what are the important things to understand, and how we use this course for learning all those important components. So before that, I see that people have joined. My name is Sitaram, and I have around 15 years of experience in IT, and out of which around 8 to 9 years we have spent in the data area. I worked as a big data architect in the past for many years, and then slowly navigated my career as a data scientist. For the past 3.5 years, I'm working as a data scientist for a multinational company, and I deal with solution designing and uh, uh, product development and other things within the scope of data science. And apart from my current work, I also do part-time trainings. This is my part-time gig. Over the weekends and over the mornings, Indian Standard Time, I take some sessions. So I collaborate with Career IT for conducting these trainings and sharing my knowledge. I do have a great passion in teaching and learning per se, and because of the passion of learning, I also can reciprocate the same thing in my teachings as well. I did my master's from BITS Pilani in data science, and I'm pursuing my PhD right now from IIIT Hyderabad. And I stay in Hyderabad, and that is my hometown. So I think these are some of the basics of my introduction. I will definitely would love to hear from all of you, but not at this point. Probably we will not waste our demo time for introductions. We will, as and when we go deeper, we will understand each other in a great detail. All right. So with that said, let me start the session. Now, today's scope of the session would be to understand what are the primary areas of concentration in data science. And there are multiple reasons why we are doing this data science course. Now, the first one could be you would like to do a job switch where you would like to upgrade your skills, that you are looking for some kind of a role switch or something like that. So in that case, you would need to have a good amount of technical and project oriented um, learning. So whenever you get deployed into one of these projects, you will know like how to use it. There are other set of people who are already experienced, who have good years of experience, like 10 to 15 years, who are in the managerial roles, who got new projects, and they would require this knowledge for essentially driving the initiatives. So I've seen many people who come from such kind of a background where they might not be doing a lot of coding, but they would require these skills for driving these initiatives, right? So they would need to have understanding of how these systems work and what are the basics of that and so on. And there are other set of people who are right out of the college, so they might have done something in the college, some language, some Java, Python, whatever kind of a skill set, and now they want to go to the next level because they would like to enter into companies which are dealing with data, which are working on application building using data and so on. So for such kind of people, we have areas where we can improvise their skills and do a lot of things. So these are some of the key people who would be looking for doing such kind of trainings. And data science is a vast area. It is comprising of multiple things. So what we will try to understand is we will try to first focus on math for data science first. Now, this is a very essential topic. In fact, a set of topics. In the mathematics for data science, we would need to understand what is a linear algebra, how do we use matrices, what is the role of calculus or differentiation, or other related things like probability and so on, and other numerical operations. It could be applying logarithmic, sinusoidal, exponential. So why do we do all these mathematical calculations for your data science? It is very important to understand. Of course, we might know a lot of things about linear algebra, how do we do matrix multiplications and so on, but we know it in a very raw form. We know it in a very raw form, saying that okay, you have a matrix 1, matrix 2, and this is how you do a multiplication. But why in the world are you doing this all activities, and what is the practical application of that is really important to go deeper into data science. So math for data science is a very foundational, and I give a great preference in understanding all these mathematical concepts. So we'll spend few days for understanding all these mathematical concepts and then dive into the next important areas. So first one is math for data science. Then we discuss about statistics for data science. So math for data science is important. Then we will discuss about statistics for data science, and statistics for data science we will also discuss about different statistical concepts which are involved in data science. So we will look at things like what are descriptive statistics, what are inferential statistics, how do you use statistics for defining the data solutions, how do you understand data, distributions of the data. All these questions come, and for understanding that, we need to understand statistics for data science, right? So after that, after we look at statistics for data science, where we get these foundations, we will get into the tools required for applying data science. We will do Python. Python is a very famous language. Of course, it has become the go-to language for applying all the data related things, and we will see like how do we apply Python for doing all the data related work. We will look at the tools required for Python, the NumPy, Pandas, Matplotlib. Likewise, there are different types of tools which are required for doing Python. We will look at all those important things. Now, once we complete all the basics, like which these are the tool sets for understanding all these things, and we will spend close to half a month here to just understand all these concepts. So once we understand all these concepts, then we get into the real part of your data science, which is machine learning. And within machine learning, we have again sub areas. We have supervised machine learning. Within supervised machine learning, we have another further sub areas. We have classification and then clustering, classification and regression. Sorry, not clustering, regression. And we have unsupervised machine learning, which talks about clustering, association rule mining, market basket analysis, clustering, association rule mining, and market basket analysis, like that. And then we will understand something about reinforcement learning. All right, so we'll discuss about these all topics. We will understand what is supervised machine learning, classification regression, unsupervised machine learning, clustering, association rule mining, and reinforcement learning. And then once we complete all these things, we will get into other important topics like natural language processing. We will discuss about something like recommendation systems, recommender systems. We'll do time series forecasting, right? Recommender systems and time series forecasting. These are some of the areas which we will use for understanding little advanced topics of data science. Once we complete all of these, we will get into another big area, which is called deep learning. Deep learning talks about a lot of unstructured data classification and regression things, specifically when we are dealing with images, videos, speech samples. So dealing with such kind of data is very difficult, and the algorithms which are working on in this area are neural networks. So we will apply these neural networks to understand what are the difference between images, object identification, activity identification. So you might have seen a lot of applications in this space where you're like Google Translate or Google um, image identifier applications. All these things would use for these applications. So we will learn about something called as CNNs, which are called as convolution neural networks, which are very popular in image and video analysis. We will learn about RNNs, which are recurrent neural networks, which are popular in time series forecasting, creating chatbots and other things. And apart from that, we will also learn about LSTMs, specifically for creating time series forecasting data and stock market analysis, chatbot creation. All those things we will understand in this space of deep learning. Apart from this, we have a very strong focus on one simple thing. So if you look at this entire data science area, now I call it as a T, where you have the depth, and then you have the breadth. Most of the time people focus on the depth. Depth involves understanding algorithms. Now you do machine learning, you do deep learning, you do X, Y, Z algorithms. This is good. This would require you to understand how do you do data pre-processing, how do you apply data cleansing, how do you apply all these good algorithms. All these things are very, very essential for working in the data area. Now I call that as the depth of data science. But apart from the depth, depth, if you know, you would get specialized in one single area. No, you might become somebody called as a data scientist. The older data scientists, they were responsible for creating new algorithms, trying to do data transformations, apply some reports, and so on. So that is the prime job of the data scientist. But the new age data scientists, they don't even they not only create the algorithms, not only apply the algorithms to the data, but they also know like how to deploy the algorithms onto real world production applications. So such kind of people would need to understand two other important breadth areas, I would call. One is cloud and the second one is DevOps. The cloud is very important because now you are seeing everything is moving on to cloud. You might take AWS, Azure, Google Cloud, you name it, any of these cloud providers. Most of them have similar kind of services, but they're catering for the one and only means that people no longer want to stay on premise because of a lot of difficulties it comes with, because of procurement, because of installation, maintenance, and all these things comes with a lot of costs. Human capital, power intensive, and maintenance intensive, and all that stuff. So people don't want to invest on procuring systems, deploying applications on the servers, maintaining them. So they are no longer doing that. They are moving on to cloud. Clouds are on demand basis. You can rent out a machine on one of the cloud provider, AWS or Azure, use it for 1 hour, do some work on that, and then you can terminate it. So once you're doing that work, what you're doing is you're only renting the machines for a certain duration, and the rents are also pretty cheap. So when you're getting your work done, why do you want to maintain a full system which you're not utilizing for the entire duration of the day? So that is the motto. There are certain concerns related to security and other things, but those are getting sorted out as and when the clouds are getting mature. So one area is cloud. So a data scientist not only building the entire stack of how these applications are built, what algorithms are used, how the data is processed, they also need to have an understanding of the cloud and DevOps. Now, DevOps is also a very, very important process-oriented approach, a methodology, which is getting implemented throughout your tech area. And everybody, it is nothing like, okay, DevOps is only for the DevOps engineers. This is that kind of thought process is slowly fading away. Initial days of DevOps, people used to get expertise in DevOps, saying that, okay, I am a DevOps engineer or I am a DevOps developer or whatever. But nowadays, there's no specific DevOps kind of a engineer developer. Slowly that is fading away, and everybody, whichever role you are in, for example, you are a front-end developer, you need to have a familiarity with DevOps. If you are a back-end developer, again, you need to have a familiarity with DevOps. Same is the case with the data scientist. He or she should know like how to deploy your models onto cloud or any other production servers, and how do you maintain the pipeline, how do you take the data, when the job should start, when the job should end, what are the connected pipelines which will be triggered, how the data would be consumed, how the data would be visualized. So these all things will be connected through the DevOps concepts. There are a lot of tools involved here. We would use Docker for containerization. We would use Kubernetes for orchestrating your containers. We would use Jenkins for automating your entire process of different jobs and different operations. All those things will be done in the entire DevOps process. So what we will do in the course is, apart from learning all these natural language processing, machine learning, deep learning, we will also concentrate on cloud computing for data science. Cloud computing for data science is one area, and then DevOps for data science in another area. All right. So apart from learning the depth, you should also concentrate on the breadth of your course. And we will be focusing on these two important areas because unless until we know this, you will not be able to be deployed in any of the projects. Like XYZ algorithm. Say like I know random forest algorithm which gives 85% accuracy. Now forget about what is random forest. We will understand that, but just imagine that there is an algorithm which is giving you some amount of accuracy, but that doesn't help you, because unless until you deploy that algorithm into the real world, which consumes new data, which can predict outputs, and it is connected to the entire ecosystem, your algorithm is of no use, right? It's just for showcasing your bosses that you have tried this and this, and it is giving so and so accuracy, so and so precision, and so on. But unless until you get deploy that application either onto cloud or onto a web application or onto a mobile application, unless until you do that, you will not be able to appreciate how this entire stuff works, right? So to just take a step back, so we would start with all these different topics. We'll get a strong foundation, we'll get into the machine learning, and once we complete all the machine learning parts, we will look at some of the advanced topics. We will discuss about natural language processing, recommender systems, time series forecasting, and then we'll get into the deep learning area. In the end, we will spend good amount of time on cloud computing for data science, which will help you so in this I will be focusing on AWS. I have a good hands-on on AWS. So we will talk about AWS for data science. We'll see like how we could deploy our machine learning models onto AWS. So all those things we will discuss in this space. And then in the Docker, we will discuss about, in the DevOps, we'll discuss about Docker, Kubernetes, and Jenkins and other things in the DevOps space. All right. So any questions so far? I'll just go through the curriculum. I'll show you like what are the things involved, but any questions so far? You can use the chat window if you are having any questions. I could put your question on the chat window.
Yeah, hi, this is Ranjit. So I have one question, like, is there any prerequisite to take this course?
It is recommended to have some programming language. If you have understanding of programming, say like C, C++, Java, or Python.
Yeah, that's fine. Like, so you're saying like, so in DevOps area, Kubernetes and other things, right? So would you explain all from basics, or else we should know some basics in those areas?
We will go from the basics itself. So by the time we reach there, you will get familiarized with what is happening. So I will kind of link it in the practical sense, like why do we use Docker, or why do we use Kubernetes, and why do we use Jenkins for relating all these things. So we will talk from the basics itself. So for that, you do not require any language per se. But for execution of this entire data science code and other things, you need to have some familiarity with language, because I will not be talking about functions and how do we define classes and variables. So that I might not be able to talking. So that's the reason.
So what about Python? So you will explain the Python concept which required for data science from basics, right?
Yeah, that will be completely covered. So if you do not know anything about Python for data science or anything about Python also, it is good. It is okay. We will discuss about all those things. So we have a separate section where we'll be spending considerable amount of time understanding all the tools and how do we write programs and codes and so on.
Okay, fine. Yeah, thanks.
So there's a question like, does the cloud computing mean SageMaker ML pipelines? We will not be doing only this cloud specific thing. I'll be talking about how do we deploy models onto cloud. For example, you already have an AWS based instance. Now I have a ML application. Now I want to put the ML application onto internet or deploy it as an application. What are the things we will do? That is what we will be covering. Right. So that, and I will also talk about SageMaker and ML pipelines, which are AWS specific, but our focus would be on the applicabilities point rather than the tool specific, because these tools are getting created by every cloud provider, and slowly things are moving towards the cloud-based things. But our focus would be how to create a basic things and how to deploy that as a as end-to-end solutions. So there are a lot of areas, of course. So we will spend 3 months. It is not 1 month. We are spending 3 months of our time. So starting, say, like mid-February. So I'll say March, April, and May. So somewhere in May is where we are focusing to close this course. So early May is the time frame which I'm thinking. All right. So I'm from a non-coding background. Will this session be helpful? Depends upon your experience. If you are a very fresher, I would recommend to learn Python. But if you already have an experience, or if you're already having working experience in some other areas, probably could be from a testing background or BA or something else, then it should be good. It should be okay. You will be able to learn Python in parallel, and you could get the work done. But somebody who is non-coding, who does not know anything about it, I would recommend to get into one language, because it is not advisable to just come into the area and you'll be blank like what's happening. So I don't want that to happen. A good thing would be to learn a language. Python is a very good language for somebody who do not have any coding background. Career IT does have sessions on Python. So I would recommend that first and then get into data science. All right. So let me show you the curriculum. It's kind of discussing whatever we have spoken right now. So this entire curriculum, I have designed it, and keeping the entire practicality in mind, I've designed this entire curriculum the way I wish to learn the course. And there will be 20 projects throughout the course. So there will be 20 projects we will be doing throughout the course. And while we are doing these mini projects, we will be learning about the tools and technologies. So that will actually solidify our understanding. So if I'm doing a project, and while doing the project, I'm learning what is the algorithm, then you will have a good understanding of how this algorithm is applied in the real sense. So we'll start with foundations of data science, where we will have some introductions to the areas: data science, AI, machine learning, and approaches of machine learning, different terminologies and other things. And once this is done, we will get into mathematics for data science. Now, this first one is kind of an introductory sessions. And then once we are done with that, we will get into math for data science, where we are doing understanding different mathematical concepts. We will talk about linear algebra, matrices, eigenvalues, eigenvectors, scalars, vectors, and tensors, different probability distributions, your conditional probability, your calculus, differentiation, gradient functions, all the mathematical concepts which we have already covered in our schooling long time ago. Those concepts will be again reiterated to understand how they are applied in data science. Then we'll jump into the statistics. We will cover descriptive statistics, different types of data, what are the measures of central tendency, measures of dispersion, measures of shape, different random values, distributions, standard anomaly distribution, probability, mass function, and other things. And then we'll get into inferential statistics, where we will talk about statistical sampling, inference, hypothesis testing, null and alternate hypothesis, different types of errors, type 1, type 2 errors, and there are different types of testing things like chi-square test, t-test, ANOVA, and other things. We will learn about those things, and we will also see like how do we apply get your t-value, p-value, your confidence intervals. Those are the things which will be used in inferential statistics. Once we understand about how these statistical things are applied, we will get into the Python for data science. Specifically, we will be using NumPy, Pandas, Matplotlib, Seaborn, Jupyter Notebook, and other things. And NumPy is a very important library. NumPy is for loading data with NumPy. We can do different comparative things. We will understand indexing, slicing, copies, views, numerical operations with NumPy, metrics related operations, aggregation functions, shape manipulation functions, your broadcasting, statistical operations, and NumPy, reshape and revalue, reshape and resize, and ravel functions. All those things will be used in NumPy. We will then jump into another important topic called as Pandas. Pandas is like all-purpose tool. We will be using Pandas for doing data operations. We will create data frames, series, and other things. Selection, slicing of the data frames could be used using Pandas. You have descriptive statistics. You're working with text data, multi-indexing, group by functions, merging, joining, concatenating. All these things will be used in Pandas. We would also look at data visualization tools. Data visualization tools are very important in understanding how the data looks like. So we will be talking about Matplotlib as an important tool, and we will also talk about Seaborn. These are used for plotting your diagrams. You'll plot histograms, scatter plots, different types of line plots, box plots, pair plots, and so on. And Seaborn is an advanced visualization library which will help us to plot even more better graphings. Like we could do violin plots, box plots, cat plots, basic grids, swarm plots, LM plots, and so on. Now, those are helping us to understand how the data looks like. Right? I would request, if you are not speaking, request you go on mute, please. Everybody, please check if you're not speaking. Yeah, thank you. All right. So what we are discussing here is the different data visualization tools. You like using Matplotlib and Seaborn. Once we understand this will help us to analyze our data. A lot of work happens in analyzing the data, identifying the right markers, identifying the right data points. We also call them as features. Which one are contributing to your output, which one are not contributing to our output. So we want to reduce this non-value added data points, because those are actually introducing garbage to your data. So if you remove that garbage, you create the clean data. Your models also do cleaner predictions. So for that, data visualization provides a very crucial role. Once we complete that, we will get into exploratory data analysis. This is the technique which will involve all the Python tools. So we will use the NumPy, Pandas, Matplotlib, all those tools together for doing data cleaning, data acquisition, data preparation, data transformation. All those things will be done in this specific area, exploratory data analysis. We will do data preparation techniques like selection, removal of the columns, transform, rescale, standardization, normalization, binary encoding, one-hot encoding, train test splitting. Likewise, there are different techniques which are used in getting that conversion done. So those are the ones which are helping you in uh, analyzing your data. After that, we get into machine learning. Machine learning is a space where we will understand about what are the different techniques of machine learning. So this is kind of an introductory topic. We will understand different applications of machine learning, classification, regression. We will get into other modes of machine learning like unsupervised machine learning, reinforcement learning. We'll look at how the model is represented, how it is evaluated, what are different hyperparameter tuning techniques for machine learning, how do you evaluate your models, estimating and predicting the models in real time. So all those things we will understand in this section. So once we understand the base of machine learning, we will get into specific areas of machine learning. For example, you go into supervised machine learning classification. There are tons of algorithms which are available in the classification area. We will cover around 7 to 8 algorithms. We will look at k-nearest neighbors, decision trees, naive-bayes, stochastic gradient descent, support vector machines, random forest, gradient boosting machines, XGBoost, and logistic regression. Some 7-8 models we will use. We will understand what are the advantages, disadvantages of the models, where to use which model. We'll do comparative analysis. We'll compare two models and see like which one is best. How do you choose a specific model for a data problem? All those kinds of things we will understand here. We will also understand about different ensemble methods. Ensemble methods are combination methods. So you could combine one or more models and create even more powerful model. So you will use techniques like bagging, boosting, voting, and choosing the best model and so on. So these are the different methods which will be used. And then we will also use model tuning like train test splitting, K-fold cross validation, variance bias trade-off, your L1, L2 norms, your overfitting, underfitting, and different learning curves like variance and bias, sensitivity, and other things. And hyperparameter tuning using grid search CV. This is also an important technique in which you can use an automated method for tuning your models. Now, respective performance measures will also be used like different measures like mean absolute error, mean square error, root mean square error, accuracy, confusion metrics, precision, recall, and other things would also be used for applying different techniques. Now, once we do supervised machine learning classification, we will get into supervised machine learning regression. Now, this is a technique in which you are trying to predict continuous values, which are like number terms. Now, I want to predict profit of a company, number of car sales, a house price, or marks of a student. So if you're seeing all what we are predicting is a number term, which looks to be continuous in the nature. So you try to predict something in the number terms. That is what we call as regression. Now, we will go in from very basics to understand all these important concepts, but just understand that regression is a separate kind of a technique. We have different algorithms here: linear regression, different variants of regressions like lasso and ridge regression, multilinear regression, logistic regression, polynomial regression, random forest regression, support vector regression. Likewise, we have different techniques which are used for your different types of models. You have respective performance measures. You have different errors: MAE, MSE, mean absolute error, mean square error, root mean square error. These are the error metrics to see like how good the model is. So for that, we will be using all these metrics. And once we complete the supervised machine learning, both classification and regression, we enter into unsupervised machine learning, which talks about different clustering techniques like k-means, hierarchical clustering, DB-scan, and association rule mining, market basket analysis, a priori algorithm, dimensionality reduction using principal component analysis. So likewise, there are different techniques which are used for applying all these different algorithmic process. We will then get into natural language processing. We will understand about how do you apply text-based analytics, different techniques in applying text analytics like stemming, lemmatization, stop word removal, parts of speech tagging, name entity recognition, bigrams, n-grams, collocations, term document metrics, count vectorizer, term frequency, and inverse document frequency. Likewise, different techniques would be there which will be used for applying your natural language processing. Natural language processing is also called as NLP and very widely used as a application area in text processing. After that, we get into some advanced topics. We'll discuss about time series analysis, ARIMA models, recommender systems. Specifically, we'll talk about content-based recommender systems, collaborative filtering. So these are some of the areas which will help us to deepen our understanding on the advanced analytics topics. Then we get into reinforcement learning. Reinforcement learning is an area where we will understand about supervised machine learning, but with an advanced feedback loop. We will apply action, reward, and penalty-based mechanisms as a feedback, and we try to reinforce your understanding of the data. So you try to improvise your model by applying these feedbacks so that next time when the model performs, it performs a little better than the previous iteration. So likewise, you have your better model creating from the previous learning. Then we'll get into AI, artificial intelligence specific areas. We will talk about neural networks, different terminologies involved in that. We'll understand what is a perceptron learning, what is a feed-forward network, what is backpropagation. We will understand different topics related to math for artificial neural networks like gradients, partial derivatives, linear algebra, different eigenvectors, and then projections. Likewise, we'll discuss all the topics which are related to that area. We will also look at the tools we will be using it. TensorFlow and Keras, these are the important tools which will be used in this particular model. And once we are done with that, we get into the specific area like deep learning, where we'll talk about convolutional neural networks, multilinear perceptrons, recurrent neural networks, autoencoders, and many other different models. We'll also understand what is the basis of accuracy measurements, what are the different application areas which are used, how to build multilinear perceptron models, how to build image classification models, how to build image similarity models. All those things we will discuss in the deep learning. Specific areas, we'll talk about convolutional neural networks. We'll understand architectural areas of convolutional neural networks, different filters which are responsible for creating CNN models, how to build a basic image classifier using CNN. Those are the ones we will discuss. After that, we get into neural networks, where we will talk about how these recurrent neurons would work. How do you handle different sequence of models like variable length sequences and so on. We will see like how to apply training as a sequence classifier, training and predicting as time series forecasting is what we will understand. Next, we'll understand about cloud computing for data science. This is where we are understanding how do you deploy your models onto cloud. Specifically, I'll talk about AWS related services. There are plenty of services which are used for doing this entire end-to-end development of the model. So we will understand about S3, EC2, RDS, and we'll understand about how do you do different data processings on EMR, machine learning using SageMaker, how do you apply deep learning on the cloud, use Amazon Lex or different other services, how do you create entire end-to-end data pipelines on AWS cloud by deploying models on EC2. So all those things we will be learning in this particular section. Last but not the least, we will also learn about DevOps for data science. We will understand about what is a DevOps and how is that used in the data science parlance. We'll see like how to deploy the models in production, deploying machine learning models as services, running them as containers, scaling your machine learning models using Kubernetes, and different other things. Those are the things which will be used, which will be understood in the DevOps way. Talking about different projects, as I said, entire course is project driven. This is a technical course. Please don't think that this is a, you know, theory oriented course and like that, but it is a technical course. You would be doing a lot of code based learning. So we will be doing a project based learning. So code based learning will also not help us because we don't know like how things are connected. If I just know about one particular algorithm, then you would not know unless until you connect all the pieces together. So this project oriented learning will certainly give us a lot of insights of how the data is procured, how the data is processed, how you apply a model, how you deploy the model, as the end-to-end solution. So all those things are very, very important. So we'll talk about these projects. We'll see like how to build an XML to CSV converter as a Python example. We will build a photo editor using NumPy and Flask. We will go and understand exploratory data analysis using retail shop sale data. You'll do fruit type prediction using k-nearest neighbor algorithm. You apply malignancy in using mammographic masses and using decision tree classifiers. You will predict whether a candidate will be shortlisted in H-1B visa processing using random forest algorithm. You will predict breast cancer using support vector machine algorithm. You will do HR analytics in attrition prediction using logistic regression. You will do churn analytics in telecommunication, predicting housing prices using regression, social network ad prediction using social media, retail customer segmentation using for spending patterns, for market basket analysis using a priori algorithm, SMS spam detection using natural language processing, sentiment analysis of restaurant reviews using natural language processing and supervised machine learning, image classification using deep learning, content-based recommender systems using deep learning, chatbots using recurrent neural networks and deep learning, stock market prediction, and exploratory data analysis on crime data in Boston. Right, so these are close to 20 projects, but we will do even more than these. I actually add a lot of projects on the go, and what I do is I encourage people to come up with their own specific areas of applications. For example, you're working in a banking, you're working in an insurance domain, or you're working in a retail sector, so healthcare, whatever. They actually come up with their own problem statements or application areas. So we will discuss them, like how do we do data science applications in that. We'll try to take some dummy data, or maybe if we get a real data, we'll take that data and we will apply that to the techniques. Right, so that's how it really works. And what we are trying to do is we are trying to apply these different techniques and applying those things in the real world. Right, I have gone a little fast, but I hope you are able to understand these different applications, or how we use these applications, all those things. I hope you are having a decent understanding. Any questions on this?
Hi, Sitaram.
Yeah.
Hello.
Yeah, go ahead.
Yeah, hi, Sitaram. This looks like a very good curriculum here. Yeah, my doubt is that uh, like I know some Python. I know the syntax. I am able to like write a web scraping project using Python in Jupyter notebooks and all.
Mm-hmm.
And like I have done a small project in Django. like it has a database and something like that. So I'm not really good at algorithms, like algorithms using binary search trees. Um, and there will be like arrays and such problems. So should I start getting myself trained in those algorithms, or should I concentrate on these bigger, like bigger concepts like pandas or deep learning or machine learning algorithms, like this stuff? Did you?
So,
Am
so
I
the
clear?
question, okay, so as a part of our course, we will be learning from the basics, like what is the algorithm, why we have done this algorithm, how is it applied. So we will learn all those areas from an algorithmic perspective and application perspective. Now we will try to blend both the theoretical concept as well as the applicability, because once you, unless until you are in the research domain, or you are doing some academics where you want to write some paper on improvising an algorithm, in practical sense, or in the real world sense, the prime focus would be like, how do you apply an algorithm in a quicker manner to get your business outcomes. And our primary focus would be that, to see like, for a given set of problem, which is the best algorithm, how to quickly apply the algorithm, how to make that model deployable, and what are the things which are required for that model to get deployed. So all those things are our prime focus, and we will learn about that part. Is that clear?
Yeah, right. So learning how to apply already built algorithm is a better way to like get placed on, right?
Yeah, that is a way to quickly iterate on your work. So what we do in our real world, in our my current work environment, is we quickly iterate over a working thing algorithm, and then give the base model as part of our sprints to the customer, so that they get some basic working structure. And then once that is there, now you get some accuracy, then you try to improvise on the model, you try to improvise on the model, make it better and better, and so on, so that the thing will be running in production as a basic version. And every other sprint you will be improvising on that, and then giving your better model till you attain one level of accuracy.
Okay, right. Thank you.
So there's the question that there will be recorded sessions. So every session will be recorded, and you will be provided with a drive access with all the recordings, code, and data sets, and all the material, whatever we will be covering in that course. Every day they will be uploaded in the particular folders. So you will be getting access to the folder. And for example, if you have missed any of the sessions, you can go and watch the recordings, and if you have any questions, you can come back the next day, or probably we could have a one-on-one session to clarify some of your doubts, if at all they are required, right? But I would recommend to attend the live sessions most of the times, so that there is a live interaction, right? So we can clarify our doubts then and there, and that will help you in a longer term. But for some reason, if you're not able to attend, no problem, you could do that. uh, you could do that in your own way, right? So what I was saying is, I think there was a small note uh, from Kerirati that from next Monday onwards, which is the 1st of March, we will be starting the course. Timings would be 7 a.m. to 8 a.m. So if you have any general questions regarding the batch and other things, anything related to that, I would recommend to contact the numbers which are given by the career IT. They will happy to help you on any of the questions. If you have any technical questions regarding the course, you can ask them. I will be happy to answer any of the questions you have. Okay, I think people are clear. So there's a question. I'm learning GCP in tandem. Okay, does the concept stay the same with AWS? Yeah, concept-wise, both are same. Even many of the services looks similar in GCP and AWS. I also have a GCP. I don't have a certification per se, but I have done a lot of courses on GCP. So there is a lot of similarity in AWS and GCP, but GCP is in a preliminary stage. It's picking up. So maybe in the coming years, if the Google rules the world, probably GCP would be the front runner in cloud computing. So maybe the future is there. So it's better to learn that. But you will find similarities in both AWS and GCP. Yeah. For people who don't know GCP, it's a Google Compute, Google Cloud Platform. All right. Any other questions? Perfect. So I think you got some gist about what we are going to cover. So we will start the sessions early next week, and we'll continue our course. As I said, to reiterate, it would be like a 3-month course, everyday course, and we'll be doing a lot of technical sessions. Definitely, it will be a good run for your learning. If you have any certain questions or some clarifications, reach out to the Career IT team. They will be happy to answer any of the questions. If there are some technical related questions, they will route your call to me, and definitely we'll talk and discuss. All right, I'll be hoping to see you in the class next week. Till then, have a great day, a great week ahead, and take care. Bye bye.